All right, I can see 50 of you here already. We have around 3 minutes to go. Good morning, Anup, Saish, Sahil. Sorry, it's early morning. Like yesterday, today also we'll make sure all of you are warmed up. Topic for today is dynamics of motion, which is also called as laws of motion. Two more minutes to go. Oh, I have not muted everyone. Just give me a second. Mute all.
Yes.
Everyone must be muted. Yeah. Dynamics of motion, there is no theory. This is only problems. So I am just going to do problems today. There's very little theory in this lesson, dynamics of motion. So I'm just going to spend the first 10 minutes doing some theory, which is all things that you know. And then we are going to do problem after problem after problem. That's what we are going to do. All right, guys, a minute to go. All right, before I start, there is a quick thing I want to know. So on the poll, not on the poll, sorry. How many of you are not part of any WhatsApp group, right? If you're already a part of a WhatsApp group of Avanti students, don't pick your hands. If you're not part of any WhatsApp group, just say yes. If you're not part of any WhatsApp group where you receive communication, click yes. If you're part of a WhatsApp group, ignore my question. Okay, so I can see 2 of you. All right. So what I'm going to do, if you are not in any WhatsApp group, there is a link I'm pasting. There's a new WhatsApp group for new students, which will be valid till today. We will move you to the existing group. Just click join that WhatsApp group through that link. Okay. This is not for people or people who are already on a group. That you already have separate groups. For those of you who do not have a WhatsApp group, please click on this link and join this group. What we will do is this group will be valid till the end of today's class. Anup, I just opened it. It was working. Please check your internet connection. I first opened it in my computer and then only checked. It is open in front of my computer right now. All right, guys, I think time to start. Okay. All right, some of you are joining class today for the first time. We are already done with 4 classes. We are now going to start off with laws of motion. I'm anyway going to be very explanatory, but there are certain things you might have missed. So please go and refer to our YouTube videos for those classes on our YouTube channel, Avanti Gurukul. So the way we will do today's class is we are basically all right. let everyone come. I'm going to wait 2-3 minutes and then make an announcement. Okay. I'm going to wait for 2 or 3 minutes. And in the meanwhile, I'm going to share my screen. Just give me a second. See my screen. Go back to notes. Go back to a new note. And we are here. All right. So today, our focus is going to be dynamics of motion, which is also called as laws of motion. Okay, this is going to be our subject for today. Now, I think as people are moving in, I want to make certain things clear. First, notes for all classes. I have posted links. Scroll up the chat window. I'm not going to post it again and again. Scroll up the chat window. I have pasted a link. Okay, even if you're a new student, you will have access to that. I just checked that it is working on my computer, so it should work on your computer as well. If not, just make sure you check your internet connection. Second, if you're not part of any WhatsApp group, if you're not on any Avanti WhatsApp group, only if you're not on any Avanti, don't join this if you're in any Avanti WhatsApp group. Click on the chat invite I have sent. Chat invite I have sent. Okay. Third, class structure today will involve only some theory because there is not a lot of theory in this lesson, plus many problems. Okay, I want all of you to remember this and understand how class is going to be. Give me a yes if you understood all these three things. Okay, got it. I think people have got it. I'm pasting the 2 links again and starting. Give me a second. So this is the notes link. Please don't put anything on chat. Just give me a second. I'm going to disable all your chat. Okay, this is the notes link and this is the WhatsApp group. So you're going to see now. Okay. So I pasted the notes link and the WhatsApp group on the Zoom chat. I pasted it at least 3 times now, so please don't ask me these 2 questions again. If it's not working, please post it on the WhatsApp group after joining it. Okay. All right, guys. We are already okay, please join that WhatsApp group only if you're not part of an existing WhatsApp group. Okay, if you're part of an existing WhatsApp group, don't join it. Okay, guys, we're now going to start today's class. It's 9:07. We have wasted the first 7 minutes. Let me set my window. All right. My Zoom is set. All right, guys. So today we are going to deal with the lesson on laws of motion. In laws of motion, typically we come across various situations where we try to analyze the forces on the body and its response to its motion. So laws of motion lesson essentially involves forces and the response of the body to forces, of a body to forces. Okay. Now, typically in mechanics, there are some type of forces. Okay. What are these type of forces? There are three types of forces. The first one is what we call as field forces. The second one is what we call as contact forces. And the third one is what we call as attachment to another body forces. So how many types of forces are there? There are three types of forces in mechanics that we frequently encounter. Okay. Now let's try to understand each of these type of forces. This theory is just around 5 to 6 minutes long. After that, it's only one problem. Okay. So let me begin with a question. Okay. What are the different forces that we know? Okay. The different forces, let me just list down. We, for instance, know gravity is a force. Then we know electrostatic forces is a force. Then we know tension is a force. Then we know friction is a force. Then we know normal reaction is a force. Right? Are there any other forces that you guys know about? Please put on the chat if you know about any other charge. Centripetal force is a force, but centripetal force is not it's a net force. It's not a force on its own. But anyway, I'm going to write it down. Centripetal force, nuclear force, both strong and weak. Okay. Then we have magnetic force. Okay, so these are the different types of forces we encounter. Someone has written torque. Okay. Torque is not a force. Torque is the consequence of a force. So please understand this concept. Torque happens due to a force. It is not a force in itself. Centrifugal force is also an effect of a force. It's not a force in itself, right? So these are different types of the ones we have written here are the different types of forces. Okay. So now I'm going to do a quick question. Okay. The way we'll do this, I'm going to first launch a poll. Yeah, there is also viscous force. Very good. Viscous or drag force. All right. Now we'll do a quick question. In fact, a series of questions. So the options for all these questions are contact forces. A is contact, B is field, C is attachment to a body. Okay. And my question to you, I'm going to give you a force. You have to tell me what type of force it is by answering it on the poll. Okay. So let me launch the poll and let me disable chat so that none of you can answer on chat. So my first question, the options are this. Question 1, gravitational force. What type of force is it? Answer it on the poll, please. The poll must be visible on the bottom right. What type of force is gravitational force? Okay, I can see one answer. Okay, I think I'll have to enable chat because none of you are answering on the poll. Okay, I've enabled chat. Okay. I can see lots of A and B. So there are some people who are answering A, there are some people who are answering B. The correct answer is gravitational force is a field force. Now, what is a field force? A field force is a force which does not require contact. So for instance, the sun and the earth are not in contact with each other, but still they exert a gravitational force on each other, which basically means the effect of a force is felt somewhere else also, and that is what we call as a field force. So a field force is something whose effect is not only felt due to contact, but is felt even without contact. It travels like a field. So imagine, for instance, in some way I can influence your thoughts by sitting here, right? I can change what you're thinking by sitting here. Then what I'm doing is I'm trying to sort of create a field which will affect changes in the system around me, right? So that's the example. That's the first example. Let's go to the second example. Friction. What type of force is it? Can we launch the relaunch the poll again? I'm also launching the poll. Answer on the poll also, please, if you can see it. Yeah, now people can see the poll. Yeah, very good. Come on, guys. There are 80 of you who have answered. Okay, some of you have answered C, but most of you have answered A. This basically means this friction is an example of a contact force. Why is it a contact force? A contact force is one force which happens only when surfaces are in contact or the bodies touch each other. Okay. So we know that, for instance, friction can only act between two bodies if there is a surface which is common to both of them, right? So there is a common surface. Only if this is there can friction act between both of them, right? Attachment force is something different. Attachment force does not involve direct contact, but contact through something. Okay. So hence we basically say that this is sort of an example of a contact force. Let's go to the third one. Electrostatic force. What type of force this is? When we experience repulsion and attraction due to electrostatic forces, what type of force is it? Let me launch the poll again. Yeah, poll has been relaunched. What type of force is the electrostatic force? Okay, I have seen around 60, 70 of you answer. Come on, guys, more of you can answer. I can see a lot of you answering on the chat. Please answer on the poll as well. Okay, I see a lot of B and C's. I think many of you must have thought that because first one was field, second one was contact, the only thing that is left is attachment, so we should answer that, right? That's not the correct answer. Electrostatic force is also like gravitational force. That's also a field force, right? So in fact, the formulae for electrostatic force and gravitational force are very similar. You must have studied for gravitational force, F was equal to G m1 m2 upon r square. For electrostatic force, the force is equal to K q1 q2 upon r square. Okay. So very similar type of forces, gravitational and electrostatic. One happens because of the masses, the other happens because of the charges. Okay. How can we experience electrostatic force? That's something when we come to electrostatics, we will come to it. Okay. But basically what happens is a smallest charge creates a field of influence, and anything that comes in that influence is basically an example of a field force. Last, tension. We all know about tension. Okay. Tell me what type of force tension is. Let me relaunch the poll. I've relaunched the poll. You can answer on the poll. Tension. I can see 70, 80, 90 of you have answered. Satvik, I'll answer your question. Let's finish answering this poll. Okay. Almost 100 of you have answered this. And I can see many of you answering on the chat. Tension is an example of an attachment force. Right? Attachment force is sort of a contact force, but is not entirely a contact force. To answer Satvik's question, let me give you an example. So we all know that For tension to act, there has to be a string or a rope which is attached to a body. Now think of it, there is a bit of a contact, but this contact is not through the entire surface. It does not need to be entirely in touch. This rope is simply a medium of transmission of the force. Medium of transmission of force, right? Also, this rope, just because it is in contact, the tension will not always be equal to a positive quantity. If the rope is slack, so for instance, if the rope basically is just loose like this, tension we know is equal to 0, correct? So only in a particular condition does attachment basically in this case lead to a transmission of force, and that type of force is what is called as an attachment type to a body type of force. Attachment to a force that requires attachment to a body for transmission. And tension is the only known example of this. Okay. Someone has asked me a question. Let me pose back that question for you. What type of force is normal force or normal reaction? Okay, let me relaunch a poll. What type of force is normal force? A, contact, B, field, C, attachment. Okay, I can see some people answering. 45, 50, 70. I think at least 100 of you can answer this. I can see some answers on the chat. Come on, guys. We have to have at least 100, 120 people answering this. I want a lot of participation from all of you. Okay. We are stuck at 86. I'm going to end poll. Okay. I think 124 of you answered the question. So the correct answer is normal force is an example of a contact force, because normal force happens only when one object lies on another object. There is normal force that is required. Okay. So these are the different types of forces that we will study in this lesson. Now what we'll do is, instead of discussing this in detail now itself, we will do different types of problems, and in each problem when a new force comes, we will basically discuss that problem in detail. Okay. So let's start with the most important concept in this lesson, which is a free body diagram. Okay. Nachiket, viscous force is basically an example of a contact force. Viscous force basically requires body, so the liquid, to be in contact with the surface. So you can say that it is an example of a contact force. Nucleus and electron, yes, Nitin is correct. Nucleus and electron is an electrostatic force. Okay. Now let's come to free body diagram. So this is the most important skill you will learn in physics. Drawing a free body diagram. It's the most important skill in physics. Okay. The reason I call it the most important skill in physics is because if you want to analyze any body's motion in physics, physics is about the study of the motion of bodies, right? If you want to study the motion of bodies in physics, you have to know what are the forces that are acting on it. So you will see from beginning in this lesson, from dynamics of motion throughout the end of physics, in every lesson you are going to be drawing free body diagrams. So all of you better know that very well, because that force is the most important skill in physics. Now, what we essentially do in free body diagram is 2 steps. Isolate all the bodies, all the systems you want to analyze. You isolate the system you want to analyze. What does this mean? If there are multiple bodies and you want only one part of the body, you basically take that out and basically just see what are the forces acting on it. Then draw all the forces acting on that body using vectors. Okay. And the most important thing is, when you isolate, you will, and I think someone has already mentioned this, represent the body as a point. So when we are drawing free body diagrams, what we will do is we are basically going to treat the body as a point, but whoever has written that, what you will study later is when you're studying extended bodies, the bodies are not necessarily points, they are extended bodies. So that's not always true, but for this lesson, we are going to treat the bodies as a point. Okay. So we, instead of telling you a general way of doing this, right? Instead of telling you a general way of doing this, what I'm going to now do is take different situations and ask you questions on how to draw the free body diagram of it. Okay. So the way I will do that question in every situation from now is, I'm going to give you a situation, draw the free body diagram, and I'm going to ask you if the free body diagram I've drawn is right or wrong, right? So what I want you to do is on the chat window, on the participants button, click yes if you feel I've drawn the correct free body diagram. Click no if you feel I've drawn the wrong free body diagram. Okay. All right. So let's start with simple free body diagrams. So the first, and we'll take each of the different forces. Let's first take contact forces. Okay. Let's take simple contact force. Let's, for instance, take normal force. Okay. So normal force happens when two bodies are essentially in contact through a surface. So whenever two bodies touch each other, there is going to be some normal force. Okay. So here I'm going to draw a okay. So this is basically a situation M1, M2. This is basically a situation. And this is basically a situation. M1, M2, M3, M1, M2. So let's call these options A, B, C. Now my question to you is, based on what you just studied, which of these does not involve a normal force? Which of these does not involve a normal force? Okay, which of these does not involve a normal force? Look at that carefully. Let me see your chat as well. I think many of you are getting the answer correct. I can already see 100 of you answering. Very good. All right. So I think this is pretty straightforward. Let me see. So the correct answer is C does not involve a normal force, because here there is contact between this surface and this surface. Here there is contact between this surface and this surface, but there is no normal force and this surface. There are three normal forces. Here there is no contact between surfaces. Okay. Pulley at the hinge will have a normal force, but if we assume it's a massless pulley, we will assume that there are no normal forces. For the masses, there are no normal forces involved. Okay. B, of course, has a normal force. See, there is a normal force in all the blue surfaces that I've drawn pages. So this will have a normal force, this surface will have a normal force, and this surface will have a normal force, right? The pulley, the rope will not have a normal force, but the masses themselves will have a normal force, right? So hence the correct option is option C. There is no normal force between the masses, Okay. So let's now go on to the next question, which is on normal force only. I just want to make sure all of you conceptually understand it. So let's take a situation. Mass 1. So there is M1, M2, M3. My question is, how many different normal forces are acting on the bodies M1, M2, and M3. Okay? Think of it. How many different normal forces are acting on the bodies M1, M2, and M3? 2, 3, 4, 5. Again, I'm going to launch the poll. You can answer on the poll as well. The poll has been launched. Okay, I can see some different answers here. Come on, guys. 90 of you have answered. All right. More than 100 of you are answered. That's very good. So basically, what ends up happening is, in normal force, you have to remember that every contact surface has a normal force. Okay. For instance, this is one contact surface. This is the second contact surface between M2 and the ground. This is the third contact surface, and this is the fourth contact surface. So M1, M2 is a contact surface. M2 ground is a contact surface. M3 ground is a different contact surface, and M2, M3 is a different contact surface. Each of them will have a normal force, which means there are a total of 4 normal forces. Give me a yes if you understood the answer is 4. Okay, I can see around 50-60 of you say yes. All right. So here is the first concept. Every surface that is touching involves a normal force always. Always. If two surfaces even touch at a point, there will be a normal force. Now let me ask you my next question. Let's basically say this is 1 kg, this is 1 kg, and this is 1 kg. Okay. Let's say the normal force here is N1, and let's say the normal force here is N2. Okay. The question is, which of these is correct? N1 equal to N2, N1 greater than N2, N1 less than N2. No, Nachiket, they all need not be to ground. Even if they are touching sideways, there will be a normal reaction. There is a poll also I have opened. You can answer this on the poll also. Okay, I can see a lot of C's here. Some B's. Okay. Majority of the answer is C. We'll end the poll here. The correct answer is C. N2 is greater than N1. Even though both are 1 kg, 1 kg contacts, the second surface has more weight on it. Hence, the normal reaction will be higher. Okay. Let me ask you the next question on normal force. Let's take two bodies. One kg, 2 kg. Let N1 be the normal force on normal reaction on 2 kg due to 1 kg. N2 be the normal reaction of the 1 kg body due to the 2 kg body due to the 1 kg body. Now my question is, N1 equal to N2, N1 greater than N2, N1 less than N2. I'm going to relaunch the poll. Let's relaunch the poll. Okay, I can see 40-50 answers. Come on, guys. Yes, Ghanshyam. There are 5 normal forces in the. There are 5. Let me check that question again. Okay, so clearly many of you are giving the correct answer here. The correct answer is N1 equal to N2. So between two bodies, if this is N1 between the same set of bodies and this is N2, for a given set of bodies, normal reactions are action reactions pairs. Normal reactions are action reaction pairs. So this is very similar. If you try to push a body, that body also tries to push you, correct? So hence we can say that it follows Newton's third law of motion, which is every action. If I exert a normal reaction on that, that will exert an equal but opposite normal reaction on them. Even if they are moving, if they are not moving, irrespective of that, there will basically be a opposite. If there is a force here, there will be a normal reaction in this directions. Chandana, I unfortunately don't know Kannada, so I can't use Kannada. So that's why I'm trying to use English in as much as possible. So there is a doubt in the previous one. Someone is saying that there are 5 normal forces. There are only 4 surfaces, though there will be 4 normal forces. So I don't know why you are saying there will be 5 normal forces, Ghanshyam. The 4 surfaces I have clearly drawn here. This, and this. There are only 4 surfaces and I've listed them down here also because there are going to be 4 surfaces and hence, which is the previous one? No, there are only 4 surfaces, so there will be only 4 normal forces. Okay. So anyway, so this was on normal force. So net, what you need to understand is that if you have a body, normal force acts towards the body. That's the first thing. The second thing, normal force acts perpendicular to the surface. And normal force is part of a action reaction pair, right? So if you have body M, all surfaces, so for instance, if you take the ground, if I isolate it, the normal force will act towards the body, it will be perpendicular to the body, and because there is a normal force on this, there will be a normal force on the ground as well. This is basically what you will do. Okay, so this is how you analyze normal forces. The reason they are called normal forces is because normal means perpendicular. Okay, now let's move to the next important force before we do some problems, which is tension. Okay, tension basically is a attachment type of force. Okay, tension is an attachment type of force. So it acts when a rope attached to a body is tight, right? The tight means not slack. It's tight and not slack. So let's give you an example. Let's basically say this is a rope and I've hung a mass. So when this is tight, what will happen is you can realize that if you try to cut this rope, there'll be a sudden force. Now, where does that force come from? One is gravity, but you will also experience a jerk. It's because this rope is under tension. There is a force there in that rope. Okay. Now, the way tension acts is tension always acts away from the body where the rope is attached. The second thing is it always acts along the rope or the string. And third is one rope always has uniform tension throughout if it is massless. Throughout if it is massless. Okay, so there are three things here. First, it always acts away from the body, it always acts along the direction of the rope, and it always, if there is one rope which is going through multiple loops, throughout that rope there will be only one tension, but that is true only if the rope or the string is massless. If the string has mass, tension at different points in the string will be different. Most of the situations you will encounter in dynamics of motion, you will see the word massless, and many of you might be wondering why is it called massless, right? It is called massless precisely to ensure that there is uniform tension throughout one rope. A continuous rope always has uniform tension. So these are the 3 points you need to remember to understand tension better. Okay. And the most important forces are always obviously tension and normal reaction. Most of the problems we will do now will also always involve tension and normal reaction. That's why I'm doing these two forces first. So let me give you an example. So let's say there is a mass like this. This is attached here. There's a pulley here. So M1, M2. Okay, let me ask you the first question. How many tensions exist here? Option A, 1, B, 2, C, 3, D, 4. Let me relaunch a poll for you. How many tensions exist here? This rope is coming through a pulley. Look at the diagram carefully. I have given this question for a very specific reason. Look at the diagram carefully. Look at the 3 rules I have written on top. Okay, especially read the third point. And assume the string is massless, obviously. Massless string. So unless stated that it has mass, you're going to assume it is massless. Okay, I can see a lot of C's, a lot of D's as well, which is very strange. Let me end the poll. Okay, so the correct answer, like I said, if you have to remember the third rule very well, one rope always has uniform tension throughout it if it is massless. So you can see here, there is one rope here. This will have a tension T1. There is a separate string here. This will have a tension T2. Here, however, you can see that the third one is the same rope going through the pulley. So this basically means this is T3. This will also be T3. Correct? Because same rope has same tension if it is massless. And the correct option is C. Give me a yes if you understood this. Give me a yes if you understood this. Perfect. Perfect. Okay. So this is a common mistake. You must have thought that there's a separate rope. This is not a separate rope. It's part of the same rope. So this is not T4. It will be T3 only because a continuous rope will be there. Who says T2? Shreyas, you cannot assert that T2 does not exist. You have no idea of the angles. So unless you know that it's slack, I have not drawn it in a slack manner. If it is tight, it will exist. Okay. It might turn out to be 0 after solving it, but you cannot say that it does not exist because there is no reason for you to believe just by looking at the diagram that that rope will be slack. Unless you calculate and T2 comes out to be 0, then basically you can say something. Otherwise, you cannot say that. Okay. Sudanva has a question. What if the pulley has friction? Sudanva, if the pulley has friction, the tension on the different sides of the pulley become different. That is something you study in first year of engineering. That is basically not something you will study now. So ignore those situations. Okay. What is slack? So let's say a rope is like this. It's not really tight. This is called a slack rope. But if a rope is tight, it's called a tight rope. A slack rope has no tension because it is loose, but a tight rope has tension, but because it is tight. Why does T4 not exist? T4 does not exist simply because I have said the third rule. One rope always has uniform tension throughout it if it is massless. Now this is a massless string and we are going to assume the pulley is frictionless. This rope, this third rope is the same rope that I've drawn here. Okay. So one rope will have the same tension throughout. That's why it will all be T3. It will not be a separate T4. Both sides of the pulley will have T3 only existing. A separate T4 will not exist. Okay. T2 may or may not exist, but Vishnu, just by looking at the diagram, you cannot say that T2 does not exist. If there is a rope and it is tight, it will have tension. Okay. In the diagram, I've drawn it tight. So you have to assume that it will have tension. Okay. So these are the basics of normal reaction and tension. We are not going to assume friction for now for the first class. For the first class, these are the only two forces that we are going to work with. Okay. Now let's get down to doing some problems based on this, which will involve free body diagrams. Now the simplest set of problems is a pulley mass problem. And I'm going to demonstrate free body diagrams using a pulley mass problem. Yes. So in a pulley mass problem, the simplest format is where you have a pulley attached to this, and on both sides of it, there is a mass M2 here. There is a mass M1 here. Okay. Now, if M2 and M1 are existing like this, the motion of both of these, there might be more masses, more pulleys also, but this is the simplest pulley mass problem. Now here, if you look at it, there are some assumptions we will make. The pulley is massless and frictionless. The string is massless. And the two bodies are, we assume them to be point bodies. Okay. Now there are three forces acting on this, right? There's one more force which we have studied a lot earlier, but we have not encountered it here. Now, there is also the force of gravity, which acts on the masses. That we already know. If M1 is the mass of a body, the gravitational force acts downwards always. It will be M1 into G. That's the weight of the body, mg. If something has mass, there will always be mg. Now to analyze this problem, we are going to separate the two bodies and draw a free body diagram and derive a formula also. If this is M1, now what are the forces acting on M1? How many forces are acting on M1? How many forces on M1? If I ask you how many forces are there on M1, all of you clearly understand there are two forces. Okay. One is obviously M1G, its mass. What is the other force? The other force is the tension. It's attached to a rope. So now we know that tension acts along the rope and away from the body. So this is tension. So there is T, there is M1G. Now what are the forces on M2? M2 is M2G And what will be the tension? The tension will be the same because it's the same rope. That's the third rule that I said. So these are the free body diagrams, the FBDs for both of the bodies. Now here is where a fundamental question comes, right? Now the key thing we use after drawing a free diagram is use Newton's second law. What does Newton's second law say? Newton's second law says that the sum of all the forces on the body has to be mass times acceleration. Okay, so let's take m1. What is the sum of forces of all the body? So now here is where we try to understand. We sometimes think which, if m1 and m2 are not known, which mass will move up, which mass will move down. So here is a small trick I want to give you. You need not worry about what is the direction of acceleration. You can assume any direction, right? You can assume any direction. If you can assume any direction, then what basically ends up happening is, if you get a negative answer, you say that the direction is reversed. If you get a positive answer, you know that your assumption is correct. So please don't spend your time worrying about the direction of the acceleration when you're writing free body diagrams. You can assume any direction, and in the end, if your answer comes out to be negative, you just reverse the direction of the answer. And if the answer comes out to be positive, you keep the same direction. So for M1, I am going to assume that M1 moves up and M2 moves down, right? If one moves up, the other has to move down. This is an assumption. You can also take the other assumption, you will get the same answer. Okay, I am going to assume this. So if the motion is in this direction, what is the net force along the direction of acceleration? Upward force is T, downward force is M1G. T minus M1G is the total force. That has to be equal to the mass M1 times A. For M2, we can say that M2G, because downward it is moving, minus T is M2A. Now if you notice here, I have written both the A's as the same. Okay, why? Because they are connected to the same rope. If this moves up by X, this will go down by X. So if the displacement is the same, the acceleration will also be the same, right? That's why I've assumed the same acceleration. This might not be true in every situation, right? You have to, there is a constraint formula that you will study later on. But for now, I've assumed both the accelerations to be the same. Okay. Now we have two equations. Equation 1, equation 2. We basically have only two unknowns. T is an unknown and A is an unknown, right? So if we add both equations, 1 plus 2, T gets cancelled out. What we basically get is M2 minus M1 into G is M1 plus M2 into A. This means A is M2 minus M1G upon M1 plus M2. So for a two pulley simple system, this is the formula for an acceleration for each of the bodies. One moves up, other moves down. Okay. Now, what is the value of tension? You substitute this in the first equation. T is M1G plus M1 into A, which is M1 into M2 minus M1 upon M1 plus M2 G. So if you substitute this, you will basically get M1 square G M1 M2 G upon M1 plus M2. So for a two pulley system, these are the formulae that you can derive also, or you can remember also. This is the value of acceleration. This is the value of tension. Okay. Let's do a quick problem based on these two formulae. Question. You have a body, 1 kg mass, 4 kg mass. Tension in the string is how many newtons? Let me give you an assume G is always 10 meters per second square unless I state it. Okay, here's a quick question. Make sure you solve it. What is the tension in the string? Okay, I think most of you seem to have got it. The correct answer is 8 Newton. I'm going to simply apply the formula for a two pulley system. T is 4 into 1 upon 4 plus 1 into 10, which is, sorry, yeah, which is 4 by 5 into 10, which is 8 Newton, which is option B. Let me give you a next question. Consider two systems. This is system 1, which has 2 kg, 3 kg. This is system 1. System 2, 1 kg and 4 kg. Okay. Let the acceleration of this be A1. Let the acceleration of this be A2. My question is, A1 less than A2, A1 greater than A2, A1 equal to A2. Okay, let me start a poll again for you. Quickly compute this and let me know what's the correct answer. Okay, I can see 12, 13, 14, only 15 answers on the poll. Come on, guys. Simple formula that I gave you. M2 minus M1G upon M1 plus M2 into. Only 40 answers. Come on, guys. You can give me more answers. Okay. All right. So let's find out the formula. A1 is 3 minus 2 into G upon 3 plus 2. A2 is 4 minus 1 into G upon 4 plus 1. So this is nothing but G by 5, which is 2 meters per second square. And this is 3G by 5, which is 6 meters per second square. Clearly, A2 is greater than A1. Okay. Where are the masses equal? The masses are not equal. The sum of the masses is equal, Vishnu. The masses themselves are not equal. That's why I gave you this question. Just because the sum of the masses are equal does not mean the acceleration will be the same. Okay. Okay. So the correct answer is, remember the formula, acceleration in a two pulley system is M2 minus M1 into G upon M2 plus M1. Tension, yes, tension will be equal. That's true. Tension will be equal. Okay. All right. Let's go to the next question. Okay. Consider a mass. Consider a system like this. This is M. This is 3M. Okay. There is one system here, M. This is 3M. Now, let's call this A. Let's call this B. All right. Now, mass of A. So this is state 1. This is the initial state. Mass of A doubles and mass of B halves in the new state. Okay. The value of acceleration new acceleration is how much? I'm going to give you options. Twice, doubles, halves, becomes 4 times, becomes 1/4. Okay. The questions will now slightly become difficult. So what I have done is, initially this was the mass. If the mass of A doubles and the mass of B halves in the new state, what will be the acceleration, value of the new acceleration? Will it double, it halve, will it become 4 times, or will it become 1/4 of the initial value? So you have to compute acceleration in both cases. Again, remember the formula. If you remember the formula, it should be fairly easy to do. And let me give you one more option. None of these. Okay, I can see some E's. I can see a lot of D's on the pole. All right. So let's do this question. So in the initial state, A1 is 3m minus m upon 3m plus m into g. So this is nothing but 3m minus m. This is g upon 2. This is the initial value. The final value A2, 3m becomes half. So that's 3m by 2. M becomes double, minus 2m divided by 3m by 2 plus 2m into g. This basically makes it m by 2 minus m by 2 upon 7m by 2 into g, which is g by 7. The modulus is g by 7. So g by 2 becomes g by 7, which means it becomes 2/7 of the initial value. Okay, this is the correct answer. Now, for the previous question, one of you asked me why is the tension the same. So tension was T is, oh, you're right, tension is not the same because D is M1, M2. Tension is also not the same. Tension will also be different. I'm sorry. So in the previous question, T1 will be greater than T2. Okay, I made a mistake. The tension should not be the same in the previous section. Thank you for pointing it out. I misspoke. Okay, so these are simple pulley mass problems where there is only one pulley and only one mass. Okay, so one pulley, one mass. Remember this formula. T is M1 M2 G upon M1 plus M2, and A is M2 minus M1 into G upon M1 plus M2. These are only in the situation where there is a massless, frictionless pulley with a massless string, and there is one mass here and there is another mass here. Don't use this anywhere else, right? These formula are to be used only for this situation. Okay, don't blindly apply this formula anywhere. Okay, tension is M1 M2 G upon M1 plus M2, and acceleration is M2 minus M1 G upon M1 plus M2. Now what we'll now end up doing is we'll now start doing some equilibrium problems involving tension. Equilibrium problems involving tension. So these are those problems where a single body or multiple bodies are attached to a lot of different ropes, and you have to basically find out the tension in each rope. Okay, so let me give you an example. Let me take an example actually. Let's for instance take, there is a body which is kept in place through two ropes. Okay, this is a 1 kg body. Okay, it's kept in place through two ropes, one making an angle of 30 degree the other making an angle of 45 degree. Okay, one rope is making an angle of 30 degree, the other making an angle of 45 degree. The value of, let's say this is T1, this is T2. The value of T1 upon T2 is equal to how much? This is the question. There is a body in equilibrium. It's held in place by two forces, which is the tension. What is the value of T1 upon T2? It's a body that is held. Okay. If a body is held in place, what is the value of T1 and T2? T1 upon T2. Root 3 upon root 2. Root 3 upon 2 root 2. Root 6 upon 2, or none of the above. These are the options. What is the value of T1 upon T2? I'll solve this problem also. In fact, let me launch a poll for you to answer. Okay, I can see 40, 50, around 60 of you answer. Okay, come on guys, at least this is not a difficult problem. You just have to draw the forces. Okay, many of you seem to have said option D as the answer. There are around only 70 of you who have voted. Okay. So the way this works is, if you draw the free body diagram, tension will act along the rope away from the body. So there is a T2 here, which is acting at an angle of 30 degree. Okay. And there is T1 here, which is acting at an angle of 45 degree. So now in situations like these, you need to resolve the forces. When forces are at an angle, you need to resolve the forces. So what I'll do is, this T1, I've already taught you resolution in the previous class, is T1 cos 45 degree in the upward direction plus T2, sorry, I'm going to just draw this again. I'm going to draw the components in blue, in yellow, so that you understand which is the component and which is the original force. So this is T1 cos 45 and this is T1 sin 45. I've always told you that the angle which it makes with the original axis is cos theta, the other thing is sin theta. Similarly, T2, this is T1 cos 30, because 30 degree is the angle it makes. The other thing would be this is T2 cos 30, this should be T2 sin 30 degree. Okay, T2 cos 30 and T2 sin 30 degree. Now, for equilibrium, what will happen? For equilibrium, net force, equilibrium means net force is 0. Net force is 0. This is what equilibrium means. So hence we can say that net force in the x direction must be 0 and net force in the y direction must be 0. In the y direction there is also an mg, so that calculation is complicated. So I'll just take the x direction. X direction force mein, on the left hand side there is T1 sin 45 degree. On the right hand side there is T1 sin 30 degree, which basically means T1 sin 45 degree must be equal to T2 sin 30 degree for the net force to be 0. The left hand force must be equal to the right hand force, right? That's why the net acceleration is 0. So now we know the value of sine 45 and sine 30. This implies T1 into 1 by root 2 has to be equal to T2 upon 2. This implies T1 upon T2 is root 2 upon 2, which is 1 by root 2. The correct answer in this case is D, none of the above. The correct answer is 1 by root 2. So remember that whenever you are given a body in equilibrium, the key concept is you write down all the forces, the net force must be 0. Only if the net force is 0 will you be able to say that the body is in equilibrium. Okay. Now let me give you one more problem. There is a mass m1 and there is a mass m2 and there is a pulley on a table. So then we can consider cos also. The angle will just be different. Okay, m1 and m2. m1 is 5 kg, m2 is 10 kg. The net tension in the string, which is massless, is how much? In fact, I want you to solve this. I'm not going to give you options. I want you to solve this for me. Okay, please put your answer in the chat. For this situation, if m1 is 5 kg and m2 is 10 kg, what will be the net tension in the body, in the rope? Since F is MA, if F is 0, A is 0. You're right. I can see 30.33, 50 by 3, 33.3, 6.66. I don't want the normal reaction, so then I want the net tension. I see 50 by 3, 10 by 3, lots of answers. So let's see how to do this. Again, we'll draw a free body diagram. Okay. So we have the mass. I'm assuming no friction throughout. Okay. This has T. That's the only force acting on it. There is an mg which is downwards. The mg is 5 into 10, which is 50 Newton downwards. And there is a normal reaction upwards. Okay. But on the sideways direction, this body has only tension. That is the difference between horizontal pulley and vertical pulley. In the vertical pulley, both bodies have gravity. Here, in this body, there is gravity, but it is not in the direction of motion. So its gravity does not affect its motion. For the second one, you have T and you have 100 Newton. Now, what will be the direction of acceleration? You can very clearly say that the direction of acceleration has to be A. Now, if the direction of acceleration has to be A, I can very clearly say that this will move with A and this will also move with A. So, if I basically find out the first equation, 100 minus T has to be 10 into A. F minus total force is mass into acceleration, right? So 100 is the downward force on this, 10g, because 10 kg mass, and T is the upward force on this. That has to be equal to mass into acceleration by Newton's second law. And for this, T has to be equal to 5 kg into acceleration. Okay. So this basically means 100, if you add 1 and 2, is equal to 15A. This implies A is 100 upon 15. Now we know that tension is 5A from equation 2. This basically means T is 5 into 100 upon 15, which is 100 upon 3 newtons, which is 33.33 newtons. Many of you got this right. Well done. Okay. We are going to do a couple more questions. We are almost at the end of the class, but we are going to do a couple more questions so that all of you basically have some idea of how to resolve forces. So I'm now going to draw an object in equilibrium. Okay. It has three forces. Yes, you can also use direct formula. m2g upon m1 plus m2 is the acceleration and tension you can find out. So a body has three forces, F1, F2 and a 8 Newton force. Okay. And a 4 Newton force. This is 60 degrees. This is 30 degrees. And this is also 30 degrees. Okay. My question to you is, what is the value of F1 upon F2 is how much? Okay, this is my question to you. 5:4, 5:1, 1:5, or D 4:5. This is a body in equilibrium. I'll go to the previous problem once again, but I want all of you to solve this now. I'm going to start a poll because by now many of you must have solved it. What is the value of F1 upon F2? Let's see, only 6 of you are answering on the poll. Well of you. Twenty of you have answered. Come on, guys. It's not that difficult. It's slightly long, but it's not that difficult. What is the value of F1 upon F2? Rajwal, please check your calculations. I'm not sure the answer is 2:1. Yes, Vishnu, this is the last question we will do. Okay, Anaga has written an answer. Anaga says option C. Srushti says it's option B. So there's a tie between 5:1 and 1:5. Okay, I have only 40 votes so far. Okay, now I see lots of answers. Okay, let's basically now understand how to do this, right? So this is a classic example of an equilibrium problem. Now we know that for this problem, the sum of forces in the x direction has to be 0 and the sum of forces in the y direction has to be 0. Okay, let's do the x direction. In the x direction, let's resolve each of the forces. In the x direction, we can very clearly see that F1 has no component because it's a 90-degree angle to the horizontal. Let's assume this is x, this is y. Okay, F1 has nothing. The 4 Newton force will have a component 4 cos 60 degree in the x direction, right? That is basically going to be one force, 4 cos 60 degree. 8 Newton force is entirely in the x direction, and F2 will have, because it makes an angle of 30 degree, will have F2 cos 30 degree component in the opposite direction. Correct? So this is 4 plus cos 60 minus F2 cos 30 degree is 0. Correct? That is the net force. You solve this. This basically gives you 8 plus 2 minus F2 root 3 by 2 is 0. Solving this, you get F2 equals 20 upon root 3 Newton. This solves for F2. You now know F2. Now we also need to know F1 to find out the ratio of F1 and F2. So we will now do sigma Fy is 0. If Fy is 0, what are the forces in the y direction? There is F1. I'm going to write it here because you can so that you can see the diagram. Right? The force in the y, you have F1. Then you have F2 sine 30 degree, which is in a negative direction. And you have 4 sine 30 degree. I'm sorry, give me a second. I'm just going to draw it again so that all of you can see it. So you have F1, you have 4, you have 60 degrees, 8, and you have F2. This is 30 degrees. This is 30 degrees. This is 60 degrees. Okay. So basically you have F1 plus 4 sine 60 degrees minus F2 sine 30 degrees has to be equal to 0 because sigma Fy is 0. To solve this, you get F1 plus 4 root 3 upon 2 minus F2 upon 2 is 0. So this basically gives you F1 is F2 upon 2 minus 2 root 3. This gives you F1 is 10 upon root 3 minus 2 root 3 because we always computed F1. To simplify this, this becomes 4 upon root 3 Newton. So F1 is 4 upon root 3 Newton. F2 was 20 upon root 3 Newton. So the ratio turns out to be 1 upon 5. That was the last question for the day. If you have any doubts, please state it. Okay, many of you can't understand this. So I'm going to draw this again. This was the last question. For those of you who understood, you can move on. This was the last question of the day. Let me repeat this again. Let me draw the diagram again so that you all understand. So you have F1, you have 4 Newton, you have 8 Newton, and you have F2. Okay, this angle was 30 degrees. This angle was 60 degrees. This angle was 30 degrees. Okay, the first thing you will do is resolve all the forces in the vertical and horizontal direction. Let's first do that. Let's first resolve F1. F1 is just going to be F1 in the vertical direction. Correct? There is no horizontal resolution. F2 is going to be, this will be F2 sine 30 degree. And in the horizontal direction, you will have F2 cos 30 degrees. Correct? That's also correct. Give me a yes if you understood these two so far. For those of you who are struggling with this, these two you understood. Okay. Now F3, now for 4 Newton, this would be 4 sine 60 degree. And this would be 4 cos 60 degree. Okay. These will be the components. And finally, there is an 8 Newton force in the horizontal direction. So these are all the horizontal components of the force. These are all the vertical components of the force. Blue represents horizontal components and green represents vertical components. There will not be 8 cos 60 degree, Vishnu. 8 Newton is the horizontal force. It is this force. So there will not be 8 cos 60 degree. Okay. Yes, there will be no horizontal component to F1 because F1 is in the vertical direction. Right? F1 is in the vertical direction. So the horizontal component would be F1 cos 90 degree. We know that cos 90 degree is 0. So the horizontal component of F1 would be 0. Okay, so this is basically how it will work. Now all that you need to do is you have to basically equate the sum total of this to be 0. So sum total and sum total of this to be 0. Here it has only one variable, so I will use this. So which basically means 8 plus 4 cos 60 degree minus f2 cos 30 degree has to be 0. That is what this will give, and that will give 4 sin 60 degree minus f2 sin 30 degree plus f1 is 0. So you get two equations. From the first equation, you will get the value of f2. You substitute that f2 value here, you will get the value of f1. And from f1 and f2, we can basically find out f1 upon f2. Give me a yes if you now understand how to do this. Frozen Shadow, if you're not getting the link of the Zoom class, join the chat invite I've posted. Okay. The Zoom link is the same. There is no difference. It's the same link every day. Srushti, yes, in the previous question, why t equal to 5a? Okay, let people note this down first, then I'll explain to you why t equal to 5a. Anaga, the notes are anyway sent. I posted that notes 5 times today, so just please check that. It's going to be on the same link. I have uploaded it there. In projectile topic, Vedini has a question. If two equations of a projectile is given, then how to solve it to find angle of projection? Vedini, you have to give me an exact question. What do you mean by two equations of a projectile? Can you post an actual question? I can help you with that. Vertical components are here. These are the vertical components. Please don't send me individual questions. All questions are to be posted on the group or asked here. No individual questions, please. I get 1,000 messages a day. It is impossible for me to respond like that. Please post it on the WhatsApp group. There are teachers present who will answer there. Can we equate vertical components directly? Yes, you can do that. Take all the vertical components. The upward vertical component has to be equal to the downward vertical component. Netaji Nayak, I have posted the notes. Scroll up. Okay. I have posted the notes already on the Zoom chat. Scroll up for the chat. You will find the notes. Okay. We will change that for now. Just wait for the end of today's class. We will change the admin privileges. Why 4 sin 60 but not 8 cos 60? Because we are resolving in the x and the y direction. 8 is already in the x direction. 4 is here. So this 4 has to be brought here. So that's why 4 cos 60 degree. 8's entire forces will be in the horizontal direction. Okay, Swikriti, I'm going to post the notes again here for everyone. I've posted the notes link. I will upload the notes for today's class in a while. So wait on that, but all previous class notes are available there. Okay, let me go to the t equal to 5a question. Okay. Let's in fact go to the question first. There is a question. Where is T equal to 5A? Okay, this one, right? The 5 kg, 10 kg mass. Okay, I'm going to draw this again. So there is a 5 kg mass connected via a pulley to a 10 kg mass. This is 5, this is 10. All right. Let's draw the free body diagram, Shreya. So you have, for this body, what are the forces acting on it? There is tension, there is mg, and there is a normal reaction. Give me a yes if you understood this much. These are the only three forces that are acting. Assume that friction is not there. Okay. Now, which way, if this is kept on a table, which way will the 5 kg body move? It will obviously move. If this moves down with A, this will also move in this direction with A. It will just follow the table. Correct? Give me a yes if you understood this much. Okay, this much also you understood. Now look at this body. This body, for this body, if you apply Newton's second law, the sum of the forces in the x direction must be mass into acceleration in the x direction. What is the there is only one force in the x direction. There is only tension, because all other forces are in the y direction. So tension is the sum of the forces in the x direction. The mass of this body is 5. Correct? That was a 5 kg body. And the acceleration is a. Hence T equals 5a. So Shreya and Srishti, I hope you understood this. I already taught you how to find A. So for finding A, so write the free body for this. So for this, if you draw the free body diagram, you have 100 Newton, you have T, and it goes down by A. So you will have 100 minus T is 10A. So you add equations 1 and 2, T goes away. 100 equal to 15A. If you do equation 1 plus 2. Okay. So this basically means A is 100 upon 15. Now because A is 100 upon 15, if you substitute it in this equation, you will get the value of tension. So Arjun, I hope you also understood this. Why 100 minus T? Because in this body, you have 100 Newton mg, no? Mg is 10 into 10. And upper there will be T. So that is why niche 100, upper T. So the net force is 100 minus T. Vasavi, I hope you understood this. Perfect. Okay. Anyway, so Medini, I will answer your question from the previous topic. Very glad that you're enjoying it. So you are given X is 36T, Y is 48T. I think 48T square hona chahiye, Medini. There is some mistake you've made. Some mistake you've made, Medini. I think it has to be, it has to be 48T minus 0.49 T square, I think. Check and tell me if that's what it is put. Yeah. So you can either use direct formula, or you know that for a projectile motion, if it's projected with U, okay, then Ux is U cos theta, Ax is 0, Uy is U sin theta, and Ay is minus G. You know all of this, Medini. Am I right? For the x direction, Ux is U cos theta, Ax is 0. For the y direction, Uy is U sin theta, and Ay is minus G. Okay. Now you just write the equation. So if Ux is this, what will be x? X will be ut plus half at square. So x will be U cos theta into t A 0, so it is x will just be u cos theta into t. Y will be u sin theta into t minus half gt square. So you got everything. So all that you need now is basically compare it. So this means u cos theta is 36, u sin theta is 48, which basically means comparing the equations, u cos theta is 36, u sin theta is 48. This basically means dividing both, sin theta upon cos theta is 48 upon 36, which is 4 upon 3. If sin theta upon cos theta is 4 upon 3, that means tan theta equals 4 upon 3. If tan theta is 4 by 3, what is the value of theta? I have taught you this. So theta equals, remember the 3, 4, 5 triangle? This is the value of theta, and that theta is actually turns out to be 53 degrees. That should be the angle of projection. Perfect. I hope I cleared your doubt, Medini. Perfect. Anaga, you're welcome. Please practice more. If you practice more, physics will automatically become interesting. We still have 2-3 more classes to go on dynamics of motion. This is the most important chapter. We will take a lot of time in this because if you understand dynamics of motion, you will understand physics. Test instructions will be given to you today evening. So don't worry. We will make sure that we give you all the instructions and give you a mock test also. All the old classes are available on our YouTube channel. Go to Avanti Gurukul. You'll see all the old classes there. They have been stored there. Thank you, Sudanva. You're welcome, students. I'm glad you enjoy it. I'm now going to end class because I have one more class to prepare for and take. I'll see you tomorrow again. Same place, same link, same time.